All right, week 8. This week's lecture is on batteries. You'll be going to deal with batteries probably much more in the future with the growth of EV vehicles. So today I'm going to cover batteries, flooded lead acid, AGMs, lithium ions, and NIMH. Oh, pardon me, I'll turn this down. Sorry about that. AGMs, absorbed glass mat, is another type of lead acid battery. The basis is lead acid. So starting with a lead acid battery, this is your 12-volt car battery, alternating positive and negative plates. They both are made of lead but slightly different, and this is what works with the sulfuric acid that is put inside. If we were to look at the plates, they would be like this, and a common negative and a common positive connection. Electrons are charged. When you charge the battery, it changes the sulfuric acid and releases the electrons which want to get to the other plate, and they will then go through our load. There's an example of a bulged lead acid battery. If your car battery looks like this, it's time to get a new one. What happens is if they get discharged, they can freeze at low temperatures. So a badly discharged or completely discharged battery basically will freeze. It will rupture, press out on the plates. The plates can touch and short internally, and then it's garbage. The greater the number of plates, the greater the surface area you have in each cell, and therefore the greater current capacity you can generate. And they're all broken up into individual cells. So what happens? When you're discharging, the chemical reaction gives off hydrogen, oxygen, and electrons. The sulfuric acid forms lead sulfate in the plates and turns to water. This is why they can freeze when they're discharged, because it's no longer sulfuric acid. There's a great video here, which I recommend you watch. A gentleman explains it really, really well. Okay, when charging, you're putting electrical current and voltage, lead sulfate and water recombine to make sulfuric acid again. And the sulfate layer on the plates turns brown to lead peroxide. So again, as long as the battery isn't overly discharged or dead, the sulfate layer shouldn't be visible. So 2 volts per cell, which is why you get a 12-volt battery will have 6 cells. And you can see that they're alluding to things like that. Now you can make a battery in different voltages, but 2 volts per cell. So temperature greatly affects 12-volt batteries, lead acid batteries. Cold reduces the cold cranking amps, and heat increases the self-discharge rate. In other words, on a hot day in the summer, a battery will slowly discharge even though it's not doing any work. And again, on a cold day in -20 in the winter, your battery does not have the same current capacity to start your car. When you're charging it, it will give off hydrogen and oxygen. Now, batteries that are vented, when you're charging it hard, you'll actually get a collection of hydrogen, which can be explosive. But under normal circumstances, especially in your car, the rate is not that strong. Now, it also can knock the sulfate layer, and the fellow in that video explains why a battery gets old and gets weak. You get a buildup of sulfate crystals on the plates. Charging it will reduce that, but over time they get more and more until it can't charge to knock them off, and it doesn't have the current capacity anymore. You can test the charge state of a battery. Generally, when it's charged, you can test the specific gravity. Sulfuric acid, it's a 30-70 mix of sulfuric acid water in a lead acid battery. Specific gravity should be about 1.3, fully charged. And as it discharges, that will go down, which means it's more water and more possibility of freezing. Overcharging causes the sediment to fall off the plates, and it can collect at the bottom of the battery. It can also get wedged in between plates and form a short. If you don't charge your battery fully, the sulfite does not get removed, and it starts to reduce the battery's efficiency. If each cell is too low discharged, under 1.75 volt, it does not clean up the plates, and now that's going to be a low battery, because you're going to be down about quarter of a volt times 6, you'd be down around 3 volts. So we're down to around 9 volts in your battery. That's pretty low. It's not going to start your car. Absorbed glass mats. These are the small batteries, sometimes called gel cells. What they do is they have a material, and they're still lead acid, but the electrolyte is absorbed in a gel or a fiberglass mat. So these things, they're sealed. Most lead acid car batteries are vented. Some are sealed. But the AGMs, gel cells, they can be turned on their side in different positions, and they still work. They still give off the byproducts of hydrogen and oxygen, but they're pressurized and sealed so the gases don't get out, and then when they're recharged, it will reabsorb all of those. So you never have to add those again. You won't have to add any water. These small gel cells don't give you the high current capacity that you get with a regular lead acid battery. So they're used for sort of slower discharge loads. A starter motor can take hundreds of amps when it starts your car. So these are used for emergency lighting where there's a fixed load, UPS in a computer, campers and such like that. They aren't flooded, so they don't dissipate heat as well. So the glass mats stop the movement of any liquid. A flooded lead acid battery does allow the liquid to move around and dissipate some heat off the sides. So they've got to be in a ventilated area, even though they're sealed. So when they say ventilated, it's not to get rid of the hydrogen, it's to get cooling air around the battery and let it cool. Because in the charge-discharge process, it will generate heat. Most battery issues have to do with improper charging. Overcharging can boil off all of the liquid, and then the battery won't work. The plates will be exposed. There's no chemical reaction, and they stop working, which is why you could check the fluid levels in your batteries. And again, it's explained in that first video. So there are special chargers for gel cells, AGMs, so that they do not overcharge. It would be based on measuring the voltage and stopping when the voltage reaches a certain point. These don't have any maintenance. Keep them clean so they don't get caked and they can dissipate the heat. You never add water. Lifespan can be up to 10 years. I think typically most lead acid based batteries, they estimate a 5-year life on those. In your car, these days with the electronics in cars, it's even less. 2 to 3 years and your battery can fail. Nickel metal hydrides, NiMH, older technology, better density than lead acid, and NiCad, not quite as good as lithium ions. Again, these are completely sealed. These would be your small rechargeables, AA's, AAA's. That's a really good use for those. Cell all contained. There's no maintenance. They just work until finally they won't take a charge anymore, and then you replace them. They only give 1.2 volts per cell. Normally pen lights, which are alkaline, will be 1.5 volts, but MINH are a little less. So sometimes devices have a setting for rechargeable batteries versus non-rechargeable. What it's doing, it's just going to expect a little lower voltage. And that's what the difference is. Pluses, long life. If they're used in an EV, good energy density. Minuses, 60 to 70% efficient. Some memory effect where if they're not fully charged, they can form crystals inside and then they can't fully charge. So they should be fully charged and quite a bit discharged. And it sort of sets a window. Then if they don't get fully charged, that sort of sets the upper limit for charging window, and then they start to, they get poor. They'll discharge less and then they'll charge less. Poor cold weather performance, and it's hard to tell when they're fully charged. Lithium ions, these are the little quarter-sized batteries, the CR2032s, 25s, that are used in small devices, good energy density and efficiency. Again, completely sealed inside. Graphite on the anode, cadmium is lithium oxide, which has disposal restrictions. You can't just throw these in the garbage. 3.7 volts per cell. And again, typically very small applications, normally. Pluses, very high energy density for the size of them. No memory, very low self-discharge rate. Toxic chemicals in these, so they must be disposed of properly. And they have to have a special charger that has a microprocessor to control the charging process. They must be not overcharged, but they must be fully charged to get a proper lifespan out of them. So in a little comparison, lead acid, lifespan 350 cycles, energy density 30 to 40 watts per kilogram, efficiency mid-range, better than NIMH, not as good as lithium ions, cheap. So again, a good choice, but very specific applications. These have evolved. So quick question, if you got a lead acid battery, 6 cells, what's the voltage? 2 volts per cell times 6, 12 volts. If you had NIMH, they're 1.2 volts per cell. So that would be about 7.2 volts. And a lithium ion, 3.7 volts per cell, that would be a little over 20 volts. So you can see the different applications of these. So the fourth type of battery, which is sort of being phased out more, are NiCads, nickel cadmiums. These have been around for quite a while. They're wet cell and cell voltage of 1.2 volts. This is according to Wikipedia. And NiCad about 1.3. And they were the choice for a long time in portable cordless power tools. Everything, photography equipment, flashlights, everything. But they've now been superseded by NIMH. And so they're kind of fading out. If you have cordless power tools, the older ones, which were 12 volts, 16, and some 18 volts, were all NiCad batteries. And the newer ones at 20 volts and so are all NIMH. So they have a longer lifespan, and they seem to hold their power a little better than NiCads. So that is one more that you're going to come across. And again, they have to have specific chargers. Everything that's going to be recharged has a specific charger that you must use with that. That's why you'll see warnings on the charger, only for use for NIMH or only for use for NiCads. They're labeled. You will see NiCad on the outside, rechargeables, and from a charger, they'll be specific for that type of battery as well.